This is Advanced Math 9.1, and these are some examples that have to do with combinations. So example A, how many different sequences of heads and tails are there if I toss a coin 7 times? And so how we can think of this is every time that we toss a coin we have two options, heads or tails. But every time we can only choose one of them, and so this is 2C1. And this time I can show you how to see that on your calculator. So I'm going to type in 2, I'm going to hit math, I'm going to go all the way to PRB, which has to do with probabilities, different probabilities. And so here's NCR, I hit enter, and so it's 2 NCR and then whatever number is next. So 2 NCR1, and it is going to just be 2. Anytime you do any number to NCR1, it's going to be whatever that original number is. So 10 NCR1 is 10. And so this is 2 right here. Now, that's not all that's happening though. That's only if I flip the coin once. If I flip the coin once, I only have two different options. I either get heads or I get tails. Okay. If I flip the coin again and I get 2C1, that would be the second time. Here would be the third time, and so forth. And why I'm multiplying these together is because this is an AND statement. I'm saying how many different sequences of heads or tails are there if I toss a coin 7 times. So the first time is 2, the next time and 2, and 2, and 2, and 2. So 2 times 2 times 2 times 2 times 2 times 2, 7 times. And now I want to know what that would be. The easiest way, though, would be 2 to the 7th power because I'm doing this 7 times. 2 times itself 7 times. And so this is going to be 128. There's 128 different outcomes. Again, some of those outcomes would be heads every single time. Another one would be heads 6 times and then tails. Right? Those are some of the outcomes that are possible if I were to flip a coin 7 times. So that's how combinations is starting to play into this. How many different license plates consist of 6 symbols, either digits or letters? And so I'm thinking of this as, okay, I have 6 spots that I need to fill, and it's digits or letters. Well, I have 10 options for digits, and I have 26 options for letters. So really, there's 36 different options. Again, I can think of this as, well, this is 36 and I am choosing 1. But we just talked about anytime that you're choosing 1, it's just going to be that original number. So I have 36 options, 36 options, 36, 36, 36, and 36. Again, I can say, okay, well, 36, and I can multiply it 6 times, or I can just say to the 6th power to get that answer. And so let's see here. I'm just going to say 2.1 billion. Okay, I guess I can copy it all down. I'll just copy it all down. 217 678 2336. That would be more exact. So I have over 2 billion different license plates that would consist of 6 symbols, either digits or letters. Again, one of these could be 00000, or just to confuse, O. So we probably would want to differentiate pretty well if we were doing license plates so that the right person doesn't get tickets. C, how many different 7-card hands can be dealt with a standard 52-card deck? Okay, so now we're still using combinations. We have how many cards to choose from? 52. And is this going to be a permutation or a combination? And so The difference again is a combination. The order in which I choose them will affect the outcome. Set that backwards. Combination is unordered. The order in which I choose them does not affect the outcome. Permutation is ordered. The order in which I choose them will affect the outcome. Well, if you've ever played a card game, it does not matter in most card games the order in which you get all your cards. As you're passing out the cards, I get 7 cards. I can rearrange them pretty quickly, and it didn't matter in which the order that they were dealt to me. And so in most card games and in this one, how many different 7 card hands can be dealt? So this is going to be 52C7. So now again, I'm going to say, okay, 52, hit math, go over to PRB, and this is NCR, and type in 7. And so again, a very large number, quite a few different options. So let's see here, 1, 3, 3, 7, 8, 4, 5, 6, 0. So 133 million different hands, right? So you're familiar with cards, I think, and so one possible hand would be all 4 aces and 3 of the kings. Okay, that would be one of the possible hands. All right, this last one is going to combine an idea that you've used before in statistics, which is the OR statement. And just to remind you, if anytime you're saying and is multiplying, or is adding, or is adding. So a new car customer has to choose from among 3 models, each of which comes with 4 exterior colors, 3 interior colors, and with any combination of up to 6 optional accessories. How many essentially different ways can a customer order the car? So, start with the very first piece here. I have to choose from 3 models. So I have 3 models, and I am only going to choose one of them. And I have 4 different options for car color, and I am going to choose one of them. And 3 interior colors, and I am going to choose one of them. All right, so these 3 different pieces already. I have 3 models, and I'm going to choose one, which means there's only going 3C1. I know that that's going to be 3 different outcomes. 4C1, 4 exterior colors. I know that is 4 options. And lastly, 3 interior colors. I have 3 choices, and I choose one, and so that's just 3 options. Again, 3 different outcomes. The next part is where it becomes a little bit trickier. It says, and with any combination of up to 6 optional accessories. Now, when we think about that, we need to understand that I'm saying and one of these things, because it says it right here. It says and with any of the following optional accessories. But here's my different options. I have 6 options, but it says up to, and so I could choose none of them. So I could say 6C0, 6C0. Or, so plus sign here, I have 6 options, and I could choose one of them. Or I have 6 options, and I could choose 2 of them. Or you guys see where this is going. 3 of them. Choose 4 of them. Choose 5 of them. Or choose all 6 of them. So again, I have this all in parentheses because it's still an and statement. It's still saying and with any combination. I just need to now list any and all of those combinations. Here they are. And so if we need to, which it's helpful right now because we haven't learned the next step yet, we're going to use our calculator. So 6, and go over here to NCR, and 0. What do you think it's going to be? It's 1. Because there's only one way. If I have 6 pies and I choose none of them, what did I do? I still have an outcome. The outcome is that I don't have pie, which was a terrible choice, but that was still one of the options. That is one option there. Right under 1. 6C1, we already figured this out earlier. Anything C1 will be that original number, so there's 6 options there. The next one, 6C2 is going to be 15. Remember, you can always go up. Oh, not on this calculator, you can't. You can edit, though. 3 is 20. 4 is back to 15. 5 is back to 6. And how many different ways, if I have 6 pies and I choose all 6 of them, again, the order in which I ate them didn't matter, I'm still stuffed. There was just one outcome, though. And so now, for the whole problem, I have 3 times 4 times 3 times this entire quantity here. And so you could enter that into your calculator, and you would get, let's see here, 3 times 4 times 3 times the quantity 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1. 2,304. So how many essentially different ways can a customer order this particular car? There's 2,304 different ways to do that. So be careful with this. Some keywords here, the and statements obviously that went through, or since this was an and statement, each time you had a comma here, it was essentially saying and it was a combination of up to 6. Up to, so that's why I went from 0 all the way to 6. Your homework is going to be page 708, 23 through 37, and 41 through 42. Okay, there will be a couple where maybe the order does matter, or it will affect the outcome, and so you want to use permutation. Again, that's going to be found in the same spot here. You're going to hit math, go over to PRB, probability, and here's NPR. So you'll be plugging in some numbers there as well. All right. If you have any questions, please email me with the question or the question number, and I will get back to you as soon as possible. Thank you.